Okay, we are Algebra 2, and this is what we're doing for the week right here. Today I'm going over 1-6. Your homework assignment is Practice A, 10 through 24 all. Tomorrow you have a quick quiz over 1-5, and then we're doing, after that quick quiz, you are going to be doing a Math Excel assignment over the equations. We understand that's what I'm teaching you today. You're going to have another homework assignment over Math Excel with that tomorrow. Homework is in the book this evening. Tomorrow is Math Excel. Wednesday, Chapter 1-6, absolute value inequalities. You're going to again have a book assignment. Thursday, I will answer questions over the book assignment over inequalities. You will have a quiz over the Chapter 1-6 absolute value equations. Okay, so you're going to have a quick quiz on Thursday over 1-6, and then also I'll be answering questions over the homework, which is the absolute value inequalities. On Friday, I will not be here. Friday, you are going to be working on Math XL. You will have another assignment. Now, what I'm going to do to make your life a little bit easier with these Math Excel assignments is I'm going to make them all due Monday at midnight. Did you hear what I just said? So, Wednesdays, actually tomorrow, and Friday's assignments, you have to work on your Math Excel. Okay? So if you're lost and you need one-on-one help, I will give you that one-on-one help whenever you're supposed to be working on that Math Excel. For those of you who do not need the one-on-one help, you can work on your Math Excel. But any questions over what I just talked about? Are we good? Next. Now, get out your worksheet, please. Your worksheet is 1-5 worksheet. Here are the answers, 1-6. Now, I want you to understand something. If you have not done your assignment, no work, no credit. Do we understand that? No work, no credit. I'll give you a couple of minutes to check your answers on those. Okay, I'm going to scroll. There's 5 through 10 there. You should be marking them wrong if they're wrong. You may jot down the correct answer, but if your work does not match that answer, you will not get credit for it. Do we all understand that? Scrolling.
Today, because I forgot mine on the table.
Bring it 2 more. Scrolling. Bless you. Okay. For 15 through the rest, please do not write them down if you got them wrong. Just mark them wrong because these are the answers and there was no work required for them. Do we understand what I just said? So please just mark them wrong because you're not going to learn anything from getting the correct answer and not understanding how you got it. Do we all understand that?
Like for 20, I put X in the middle and just like the sign on top. You know what I mean?
No.
No.
Wrong. I'll talk to you about that in a moment. Tim?
Put and in the middle of those two, right? Instead of like
Where?
X.
Which number?
18.
18, do not put and. It is an and graph. You are correct on that. But the and would be very redundant because what this is it means that X is trapped in the middle. Now let's talk about 18 through 22. I've had a couple questions already, so let me go over these quickly. What you need to understand is on number 18, this is an and compound inequality. Why is it an and compound inequality? Because the shading is trapped between these two numbers. It's kind of like your balls, and you take a bouncy ball and you slam it down the ground as fast as hard as you can, and what happens? It's going to bounce back and forth between those two walls until eventually it's going to what? Stop. What we call this is the trapped ping pong concept. That's what I call it. So what we have is the X is the shading, so that's why X is in the middle. The X is right there. And then I'm going to put the two walls on the outside. The two walls are your -8 and your 5. And then my question I ask you is what is the relationship between -8 and 5? -8 is always what compared to 5? Less than. Can it be anything else? No. So the symbols that you're going to use whenever you have an and is going to be less than or less than or equal to. How do you determine which symbol you use? You look at the dot. Is that -8? Is it open or closed dotted at -8? Closed. What does closed indicate? That it can be that value, which is why you have -8 is less than or equal to X. Now look at the 5. Is it open or closed at 5? It's open, which means what? It cannot be the value 5. Do we understand that? So this is a compound inequality, and then it's an and compound inequality, and it says that -8 is less than or equal to X, which is less than 5. In other words, the only value that X can take on are the values between -8 and 5. Did you hear the and there? Between -8 and 5. Okay? When you read it from left to right, it's -8 is less than or equal to X, which is less than 5. Does everybody understand that? You will see it again. Now, if you're looking at number 19, is that a compound inequality? No, because X is not trapped, and there's only one direction. That one direction, the shaded represents the X, and X has to be what? Greater than -4. Now, look at number 20. Number 20, you cannot do this. How many of you did X this way? How many of you did something that looks like that? Now, is -5 ever greater than 3? You have to be able to remove this X, and that has to be a true statement. -5 is never greater than 3, is it? So if you remove the X, you need to make that a true statement, which is why you have to make this an or statement. Because it can be this region, meaning it can be below -5, or it can be this region, meaning it can be above 3. Or, do we understand that? So how do I denote that region on the left? X can be less than -5 because it's an open dot. And then over here, X is greater than or equal to +3 on the right-hand side. Taylor? You can do it with the and only, but you have to have the same symbols, less than or equal to. But with the or, you have to put the or in the middle. Okay? Do we understand that? Now look at number 21. Why is 21 this one? How many of you put... Don't even know. How many of you wanted to put something that looked like that? You can't do that. It's not correct notation. Okay? I understand where your brain is coming from on that, but it is never good quote. It's not good to do that ever. Like my brain can't even wrap around that very well. So we're just going to erase that. What this says is the entire line is highlighted there. The entire line is shaded except for what value? So that means adding x can be any number except for -3. Do we understand that, yes or no? Okay. And then the last one is going to be an and again, which is why you're going to have the 1 is less than 6. That is a true statement, and it's trapped between 1 and 6.
21, don't you have to put both signs?
No, I'm trapped. X is in the middle. I put the one wall, which is 1. I put the other one, 21.
Yeah.
I'm sorry. Repeat.
When you have to put both signs be less than equal to
Because as soon as I say x cannot be -3, what can it be then? Anything else? Make sense? Okay. Are we good on this back page? All right, are there any other questions over? Are there any other questions over this? No questions over the front page, 1 through 10? No questions over 1 through 10? I'm sorry? Well, that's not helpful if you don't have any questions then. So which ones would you like me to do?
I got 2
Number 8. 8 minus 1/4 times 2x plus 4 is less than -3 times 1 minus x. Okay, if I'm doing number 8, what do you notice that's ugly about this problem? Fraction. Where's the fraction located? Outside the parentheses. So do I need to distribute? I don't need to distribute the -1/4, but I can multiply by the LCD to get rid of it. Do we understand that? So what is the LCD in this case? It is 4. So do I multiply or divide? Multiply 4 times 8 because it's not a fraction. Do I multiply or divide? I divide because it's a fraction. So 4 divided by 4 is 1. I bring down the jump. Do I flip my sign? No, because I didn't multiply or divide by a negative number, so it stays less than. And what is 4 times -3? That's -12 times 1 minus x. Now, what do you do? Distribute. So this is going to be 32 minus 2x minus 4 is less than -12 plus 12x. Now what do I do? Combine my terms on the left-hand side. So 32 minus 4 gives me 28 minus 2x is less than -12 plus 12x. Now what? I'm going to add 2x to both sides because I'm going to always get rid of the smaller x first. So I have 28 is less than -12 plus 14x. Now what? I'm going to add 12 to both sides. That's going to give me 40 is less than 14x. Should I flip my sign? Why? I didn't multiply or divide by a negative number. So now what do I do? Divide both sides by 14, so I'm going to have 40 over 14. Do I flip the sign? No, it's less than x. Now you tell me, can I reduce that? What is 40 divided by 2? 14 divided by 2 is less than x. Now, do I like it this direction? Do I like having the x on the right-hand side? No, pick it up and flip it around. Put the x on the left, put the 20 over 7 on the right. Now, where's the arrow currently pointing toward now? The 20 over 7. So when I flip it, pick it up and move it, it still needs to point where? So I have x is greater than 20 over 7. So I'm going to put 20 over 7 here. Is it opened or closed at 20 over 7? Why is it open at 20 over 7? Because it cannot be 20 over 7. In which direction do I shade? To the right. Do we understand that, yes or no? Taylor? Number 5. -8 is less than 2 times n plus 1, which is less than 2. Now, what do you notice here? What type of inequality is this? It's an and compound inequality, meaning I have 2 inequalities in one. So if I were to cover up this inequality symbol, what would you do? You distribute. So this would be 2n plus 2 is less than 2. We'll just drop down to -8. What would you do now? You'd subtract the value 2 on that one. Well, now I have another problem over here. What do I do on this problem? Subtract 2. So now I'm going to subtract 2 on the left, the middle, and the right. I'm doing two problems at one time. Do you understand that? So what is -8 and -2? -10 is less than. That's gone. I'm left with 2n, which is less than 0. Now what do I do? I need to solve for n. I have 2n now, so what do? I'm going to divide the left, the middle, and the right by 2. So -10 divided by 2 is -5. Do I flip the sign? No, it stays. The 2's cancel out, and I'm left with n is less than. 0 divided by 2 is 0. Is -5 always less than 0? Yes. So how do I graph this thing? I put -5 on the number line and 0 on the number line. It's open at -5 and it's open at 0, and n is what's trapped in the middle. Do we understand that, yes or no? Haley, are you good?
Yeah.
Okay. All right, now what do I want you guys to do tonight? I want you to fix 1-5 worksheet for a quiz tomorrow. Any questions over what I just said? Okay, get out your notes. Tonight's homework is chapter 1-6, practice A, 10 through 24 all. Check your answers. Now, I am recording, aren't I? You guys are used to listening to a video at home, yes? At home, you can pause me, you can rewind me, and all that jazz, correct? You cannot do that in class. I've answered several questions for you over 1-5, which means I've lost some time to go over 1-6. Now, I'm going to go relatively quick. You may not get all the notes down. If you don't get all the notes down, where can you find the notes at? On Edmodo. Do you have to listen to the video to get the notes from Edmodo? No, I post them out there in PDF format. Do you understand that? Okay? So today I'm going to talk to you, I'm going to teach you. You write down as much as you can. What do I really want you to write down today are the examples. Any questions over what I just said? Okay? So here we go. What are we talking about? We're talking about absolute value today. Now, if we're talking about absolute value, the definition of absolute value is this is a number is away from 0 on the number line. So every time you think absolute value, what should your brain be thinking? Absolute value is distance, which means if it is distance, that means a distance can be what? Measured. Now, who in here has ever watched the movie Ferris Bueller's Day Off? Okay, several people have watched it. If you have not, it's a classic. It is from the 80s. It's a wonderful movie. It comes up with that lovely little comment of anyone. Remember that comment from a teacher? That is a quote from that movie. Now, the relevance of this is the fact that the two boys took their father's car, one of the children's car, and they drove it around town. It was a Ferrari or maybe a Porsche, I don't remember. And what happened was the father checked his miles. So they got all these miles on this vehicle. And then they're like, how do we get these miles off? Well, what they did is they jacked up the car on blocks, and they put it in reverse. In high hopes, what would happen? That in reverse, that all the miles would come off the car. Well, what do you think happened? It made more miles. Why is that? Because even though I'm traveling in reverse, I am traveling a distance. And distance can physically be measured. Do we understand that? Now, eventually, what was really funny is they put the brick down and it got off the blocks. And what do you think happened to it? It went off in the back through the glass garage. It was quite beautiful. Okay? Now, the reason why I'm talking about this is because distance can be measured, and that's what absolute value is. Now, if I ask you, the bars indicate absolute value. Okay? The absolute value of 8 is what value? 8. So what you're telling me is the absolute value of 8. It is 8 units away from 0 on the number line. True statement? What about -8? So you're telling me That negative 8 is also 8 units away from 0 on the number line. So is this a true or false statement? That there exist two numbers on the number line that are the same distance away from 0 always. That's a true statement, always. That there are two numbers, two unique different numbers that have exactly the same distance away from 0 on the number line. Which means, quickly before we do anything else, I want to do this lovely little order of operations problem that involves absolute value. Whenever we do order of operations, which direction do we work? Left, right, and we need to pretend that those bars are parentheses, so let's work inside those bars first. What is 8 minus 2? Minus negative 14 plus 9 is negative 5. What is the absolute value of 6? 6 minus, what's the absolute value of negative 5? What is 6 minus 5? 1. Now, I'll be honest, why am I continuing to throw at you order of operations? Because you guys continue to not do well at it. So it's going to be there always. This concept is over absolute value, which is why you have an absolute value order of operation. Now let's talk about what we're really going to be doing today, which is going to be absolute value equations. An equation means that you have, what makes an equation? What does it have to have? It has to have an equal sign. So what we're talking about today are calculating absolute value equations. Now, I just talked to you about why we had to have two numbers with exactly the same distance away from 0, right? Because there's two numbers out in space that have exactly the same number of units away from 0 on the number line. Which means if I'm dealing with absolute value on the number line, it has to imply that whenever I'm dealing with it with equations, I also have to have two what? Answers, right? Because if I had 2 on the number line with negative 8, then I have to have 2 with equations. So anytime you're working equations, you have to have case 1 and case 2, always and forever. Why is this? Because you have the positive case and the negative case. Positive case and the negative case. Now I tell you guys this every year, and students every year, do not do case 1 and case 2. If you do not do case 1 and case 2, then you are going to fail this section. Okay? Now, the next thing you need to be worried about in this section is what we call extraneous solutions. Extraneous solutions are solutions that, whenever you find them algebraically, appear to be an answer, but whenever you plug and chug the value back into the actual equation, the left-hand side does not equal the right-hand side, therefore producing a false statement. Do we like false statements or true statements? We like true statements because we know then that it's a correct answer. Does that make sense? When you plug and chug and you get a false statement, that is calling that type of solution extraneous. Algebraically it works, but it's really not. It's a false answer. That's what extraneous is. So now let's go to the meat and potatoes of this lovely little section. For the meat and potatoes of this section, very easy concept here. I give you what is the solution of the absolute value of 2x minus 1 is equal to 5. Now, what did I just talk about whenever solving absolute value equations? What did I say was very important for you to do every time? Do what's inside the bars first. Yes, you're right. However, what did I say I tell every year my students to do and every year they don't do it? Case 1 and case 2. So do not pass go, do not collect 200. The first thing I want you to do is I want you to immediately do case 1, case 2. Case 1, case 2. Okay, so case 1 says we have the positive case, which means it's simply dropping the bars and having that regular equation. That's case 1. That's the positive case. What's case 2? Well, what did we say case 2 was before? The negative case. Well, the negative case is going to be simply putting a negative in front of it and solving for it. Now, in your textbook, they have it being the negative on the other side, meaning 2x minus 1 is equal to 5, and 2x minus 1 is equal to negative 5. I do not want to teach it to you in that manner, because I want you to do exactly the same procedure with equations and inequalities. Okay? So I want you to be on autopilot for both processes. I don't want you to think that there has to be two different processes. What happens is with inequalities, you guys forget to put the inequality symbol. And then you jack up the whole thing. So I don't want you to do that. So let's go back to case 1. I need to solve this thing. So what do I do? Add the 1. 2x is equal to 6. Divide by 2. X is equal to 3. That is a possible answer. Now how do I know if it's extraneous or not?
Solve this.
Nope. How do I know if x equals 3 is an actual answer? I need to plug and chug it. So if I plug and chug this, I have the absolute value of x minus 1 is equal to 5, and I plug in x being 3. So 2 times 3 is 6 minus 1 is, and the absolute value of 5 is? Does 5 equal 5? This is a true statement, so therefore, this, x equals 3, is an actual answer. It is not extraneous because I got a true statement at the bottom, didn't I? So now I need to do what with case 2? I need to come over here to case 2 and I need to solve it. So if I'm solving case 2, I distribute the negative. Now what? I need to subtract 1. So negative 2x is equal to 4. Divide by negative 2, and I have x is equal to negative 2. Now what do I need to do to verify that this is an answer? Plug and chug. So now I'm going to have the absolute value of 2x plus or minus 1 is equal to 5. Plugging in negative 2 there. And that's going to give me negative 8 minus 1. Why did I plug in a 4? I don't know. Didn't mean to do that, folks. So that's going to be negative 4 minus 1, which gives me a negative 5. And what is the absolute value of negative 5? 5. Does 5 equal 5? Yes, that's a true statement. So therefore, I have 2 answers. Do they both work? Yes, they do. Do we understand that process? Yes or no? Ready? What? That's the bar. Okay. Okay. Now, what if I have something that looks like this? The absolute value of... Yes, both answers are the absolute correct way to do it. Okay, now what did we talk about with absolute value? Absolute value is what? A distance. What can we do with distance? Measure it. Can you ever measure in negative distances? No. So what you're telling me is the absolute value of this jump right here has to always be what? It has to be positive. And I'm telling you that that's going to equal what? A negative. Are there any alarms sounding off in your head right now? Can a positive ever equal a negative? Can positive $25 equal negative $25? If it does, we're up the creek, right? So my question to you, is this true or false? It is a false statement. Can this ever happen? No, since this can never happen, this is what we call no solution. I could do the math. I could do case 1 and I could do case 2. And what do you think is going to happen? I'm going to get a false statement. Just to prove this to you, let's go ahead and do case 1. So what is case 1 of this? Case 1 says to do what? Take the bars off, set it equal to negative 3. What's case 2? Make it negative times the 3x plus 2, and that has to equal negative 3. So if I solve this thing, I'm going to subtract 2, and I have 3x is equal to negative 5, so x is equal to negative 5/3. There's my possible answer. I already know what the answer is. What is the answer going to be? What's the answer going to be to this whole entire thing? Not true. No solution. Okay? Well, I need to check. Why is this thing called no solution? Because if I plug in an x plus 2, if I plug in negative 5/3 here, 3's cancel out, and I'm left with negative 5 plus 2. And what is negative 5 plus 2? Negative 3. And what is the absolute value at negative 3? Does 3 ever equal -3? No, this is a false statement. So therefore, can this -5/3 be a solution? Do we understand that that cannot be a solution? That this does not work? Yes or no? We get that? Now, can I solve case 2 and do the same thing? I can. And what do you think I'm going to get for that? No solution. Now, do you guys want to show all this work? Or do you want to say, hey, that has to be positive, and that positive is equal to negative, so is that ever possible? You can take the long winding road, or you can take the shortcut and say that's never possible, and show me why. Do we understand that? Okay. Now, tell me what case 1 and case 2 is here. Case 1, 3 times x plus 2 minus 1 is equal to 8. And now what's case 2? -3 times x plus 2 minus 1 is equal to 8. Do we see that? Yes or no? Do you see how even though we had other junk on the same side as the absolute value that it didn't matter, we just put a negative in front of it? Do we all see that? We good? Now, could we solve this if we wanted to? We could, but I'm going to, since we're low on time, I want to go to one that is actually going to be very important that we talked about. What is different about this one compared to the other ones that we just talked about? Sorry? It equals another expression that has a variable in it. Now, when you have an absolute value with a variable in it equal to another expression with a variable in it, you will have extraneous solutions generally about 90% of the time. Do we understand that? So it is important that you plug and chug every time to make certain that it is not extraneous. So what is my first case 1? Case 1 gives me 3x plus 2 is equal to 4x plus 5. What's case 2? Negative times the 3x plus 2 is equal to the 4x plus 5. Do we see this, yes or no? Okay, so let's proceed to solve case 1. So case 1 gives me subtracting 3x. 2 is equal to x plus 5. Subtracting the 5, I get -3 is equal to x. Now how do I know if I'm right? What do I need to do? I need to plug and chug. So I'm going to go ahead, I'm going to grab this absolute value 3x plus 2 is equal to 4x plus 5. And every place I see an x, I'm going to plug in -3 on the left and the right hand side. So 3 times -3 is equal to 4 times -3 plus 5. -9 plus 2 gives me a -7. And what is the absolute value of -7? 7. Now I need to compare that to the right hand side. What is 4 times -3? -12 plus 5 gives me a -7. Do those equal each other? No. So since this is a false statement, you tell me, can this value of x equal -3 be a solution? No, I crossed that out. It's not possible. Which means my only solution can now come from which case? Case 2. So now I come over here to case 2 and I start to solve that. I distribute -3x minus 2 is equal to 4x plus 5. Now I'm going to add 3x to both sides. -2 is equal to 7x plus 5. And now I'm going to do what? Subtract 5 from both sides. -7 is equal to 7x. Divide by 7. -1 is equal to x. Do we all see that? Now I solved that very quickly because I already know you guys know how to solve equations. Okay? Now I need to plug and chug and I need to check this. So the absolute value of 3x plus 2 has to equal 4x plus 5. Every place I see an x, I plug in the -1. Okay, so that's going to be -3 plus 2, and that's going to give me -1, and 1 is what my absolute value is. -4 plus 5 is equal to 1. Does 1 equal 1? Yes, it does, and now I know that that's a true statement. So therefore, this is my only answer. Do we all understand that? Now, tonight for homework, you know what it is. I already told you that it's going to be chapter 1-6, practice A, 10 through 24 all. Check your solutions. I expect you to come in here tomorrow with your homework done. Tomorrow you will have a quick quiz right away. Over 1-5, when you are done with your 1-5 quiz, you will then log on to Math Excel and create and start your Math Excel homework. Have a great day.